Hi everyone! So this video is about recursion, and in this video I'm going to do an introduction on how recursive functions work. Now it's important to understand recursion because recursion is used in some of the algorithms that we study, such as merge sort and quicksort, and it's also the way that you would write some of the functions, like when you use certain data structures like trees, because it's just easier to write it recursively than it is to write it iteratively. So let's get started. Now, um, when we're talking about recursion, um, a recursive function is any function that calls itself. Okay, that's recursion in a nutshell. Any function that calls itself to solve the problem that it's trying to solve is a recursive function. Now, to understand how they work, because sometimes they look like they shouldn't work, what we need to do is we need to understand what the runtime stack is doing. Okay, so you may have heard of the runtime stack in your previous programming courses, but here you really need to pay attention to what a runtime stack is, because this is the thing that will allow recursive functions to work. Recursion will not work without the runtime stack. Now, quick review. A stack is, when you visualize a stack, it's a data structure that basically orders things in a first in, last out manner. Think of it like a tray, like a cafeteria trays, okay? If you go to the cafeteria and you see a stack of trays, the tray that you use is the one that's at the top, okay? And if you were to take a tray and put it onto the stack, you would actually put it on top as well. So the tray that you take off is the one that was most recently added, okay? So this idea is the way that function calls are actually tracked. So when you first start off in your main program, you think of it as putting down a tray. If you call a function, you put another tray on top of that. And if you call another function, you put another tray on top of that. And when you finish with a function, when you say return, you take the tray off. Okay? So this is sort of the way that we have to think about how function calls work. Okay? Now, this may not have been something that you really paid a lot of attention to, but this is essential to understanding recursion. So let's take a look at a recursive function. So this recursive function is sort of standard recursive function number one. So if you ever study recursion, this is probably the one that you begin with. This is the factorial function. Now, the factorial function mathematically is represented as an exclamation mark, and it calculates n times n minus 1 times n minus 2 times n minus 3 all the way down to 1. One of the things to note, 0 factorial exists and its value is 1. So make sure that you understand this, because it's part of the way the function has to work. So factorial of n is simply calculating this expression right here. So this is what it's supposed to return. Now, one way to write it is, obviously you can use a loop, right? Because it's going n minus 1, n minus 2, etc. So you can have a loop that runs from n, goes all the way down to 1 inclusive, and then multiply each of those together in a loop. That's pretty standard, pretty easy to write, right? So it's just multiplying all these numbers. Now, the recursive version, however, looks like this. And there's no loop, okay? There's a recursive call. But how does this actually work? So we're going to step through this code to sort of explain how it works. Now, I'm doing it with an example size of 4, so we can do a quick calculation on what this is. So this is 4 times 3 times 2 times 1, and if you do the math for this, this is 12 times 2, which is 24, right? So check my math, but it's 24. Okay, so that's the number. That's what it should come up with if I made this function call. So at the end, x should have a value of 24. Okay, so let's walk through this code step by step, and we're going to do it a little bit differently. We're going to be using, we're going to draw a picture of the runtime stack as opposed to whatever way you guys do walkthroughs these days. I think things have changed since I last taught IPC. So let's take a look at how this would work. Okay, so when the program begins its life, you would write Python, right? Python, and then fact.py, whatever, and then it would start. And this is effectively called, it's like when you start main, right? When you run the main function, it's the same thing. So this particular line of code here, x equals to fact4, okay? this line of code is effectively the first line in your main program, if you will. Now, what this means is that when I make this statement on the command line, there's a local variable called x that is created. So x is a local variable, and it's going to be assigned the value fact of 4. We're going to make the function call, and whatever it returns, I'm going to put into x. Now, at this moment, I actually don't know what x is because I haven't finished the function call. I haven't made the function call yet. So how do I know what it is? So what this means is that I'm going to make a function call, right? Like that's literally what this says, make a function call. So whenever you make a function call, you're going to put a tray onto the runtime stack. So this is factorial of 4. That's the tray. So I'm labeling it as fact4 because that's what I'm calling this with. And when you make the call, what's on the tray are the local variables. In this case, there's a local variable, an argument called n, as well as a value here, rc. So those two are basically local variables. So I'm going to declare each of them and put in their values. Now, n is what I call the function with, so its value is 4. Okay, because I made this function call right here with 4, so n and at this point is 4. Now, what about RC? RC is a local variable whose value is initially 1. So that's what this line of code says. I'm just going to track that, okay? And that's it, okay? So this is how we begin. Now, these are local variables, so as I update them, I'm going to modify these numbers as I go, okay? Now, at this point, we're going to check this line of code if n is greater than 1. And this statement, well, n is 4, so it is definitely bigger than 1. So let's do that. Okay, let's make this calculation. So this statement right here, this is true. So since it's true, we're going to do this code right here. Now this is going to change RC. So instead of RC being equal to 1, RC is now equal to n, which is 4, plus multiplied by the factorial of n minus 1, which is 4 minus 1. Right? So I'm going to have to make this calculation in order to figure out what this RC value is, right? So good, but this is a function call. And so before I can finish this calculation, the first thing I have to do is do this function call, right? So what that means is that I'm going to have to take this and I'm going to have to put this, oops, I'm going to have to put this onto my runtime stack. So my RC at this point is, so now what I'm doing is I'm making this function call. Now 4 minus 3, that's really just 3, right? So I'm going to make this function call, and now the function call is fact using 3 instead of 4. Okay? Now, we now repeat this process. There's a local variable n, and there's a variable called RC as well, right? N and RC. Now, there's an N and RC here, there's an N and RC here, but they're not the same. So to do an analogy, when you go to the cafeterias, sometimes they have that paper on top of the tray to keep it clean, right? That paper. Just because every single piece of paper looks the same doesn't mean they're the same piece of paper, right? So this is the same idea. These are like the papers that you would put onto the tray. Just because they might look the same, they have the same names, doesn't mean they are the same variables. They're different. Okay, so same idea here. These things are sitting on top of the fact3 tray. They are different from these two that are sitting on the fact4 tray. Okay, so these variables, both named n and rc, are not these two. They are separate. They're in a separate tray. So this variable n, this value is 3. This rc variable, well, initially it's assigned the number 1, right? So there we go. I don't know. There we go. Okay. So this is what we have here. Now, we do this again. Is n greater than 1? Yep, it's 3, so it's greater than 1. So now we're going to go and do this statement here. So this RC is going to be changed to whatever its n is, which is 3, multiplied by the factorial of 3 minus 1. And I have to figure out what this will do before I can make this calculation, before I can finish this. So at this point, I have to actually call another function, fact of 3, fact of 2 actually. So 3 minus 2, 1, sorry, 3 minus 1 is the number 2. So what I'm going to do now is I'm going to put another tray on top of this. So I keep getting the wrong pen. There we go. This is fact of 2. So fact of 2 is another function call, another tray on top of my runtime stack. And when I make this function call, again, there are two variables, n and rc. So n is equal to 2 and rc is equal to 1. Okay, so I'm just going through the code. Okay, I passed in the number 2. This is why n is 2. rc is 1 because this line. We step through this. Now, is n greater than 1? The answer is yes, it's greater than 1. So what do? Well, we're going to put another tray on top of this. And, oh, sorry, not yet. We're going to have to do this line of code. So this, again, we're going to change this from 1 to being whatever n is, which is 2, multiplied by the factorial of 2 minus 1. Now, what's 2 minus 1? 2 minus 1 is just 1, so we're going to change this to 1. And this means before we can do anything else, we have to make another function call. We have to call fact again. Now, that leads to this. So this is factorial of 1. Okay? So we're making just another function call. This is just another function call, and it's another tray. Again, we have a variable n, whose value is 1. And we have a variable rc, whose initial value is also 1. Okay? So we step through this code yet again. Now this time, though, it's a little bit different because this statement, n greater than 1, n is 1, 1 is not greater than 1, so this statement is now a false statement. So what does that mean? Well, since this is false, we're not going to do this line of code here. We're going to skip it, and we're going to do the return right away. So at this point, we return RC. We're not doing anything else. Now, RC's value is 1. So what does that mean? Well, when we see the return statement, it's basically taking the cafeteria tray off and giving whatever return value it is to this. Okay? So here we go. We're going to take off this tray, and we're going to take whatever's in RC, which is 1, and we're going to replace that function call with the number 1. And there we go, that's done. So what is 2 times 1? Well, 2 times 1 is just 2. So we're going to get it to 2. And at this point, we have completed this calculation. So this statement changes from 2 times 1 to just the number 2. And we are done. So now we hit the return statement. So what does that mean? Well, it means that we're going to take the number 2, and we're going to basically replace this function call with it. So this thing is now going to be turned into whatever my return value is, which is 2. And the tray gets popped off from the stack, from the runtime stack, because I'm returning, right? So I'm done. Now, what is 3 times 2? 3 times 2, well, that's just 6. So we're going to make that calculation. So RC at this point is no longer an unknown expression. It is the number 6. We've made this calculation. So now that this calculation is done, we're going to return RC. So this function call is going to take the number 6 and basically put that as the result of calling factorial. And this fact of 3 tray is removed because I'm returning. So this is the expression we're left with. So 4 times 6. 4 times 6 is 24. And then, so there we go, 24. And now 24 is what we calculate for RC. So our expression, this expression here, is now calculated to being 24. Okay? So what does that mean? Well, it means that we're now going to return 24 to the calling function. And that basically will turn this into just 24. Again, we take off the tray because our function has returned. We're done. And that's how x becomes 24. Okay, so this is how recursion works. And I just realized I had erased this by accident. There we go. So that's how we get to that point. Okay, so hopefully this is a useful explanation of how the runtime stack comes into play. And when you see more examples of recursion, you will see this. Now, I'm going to do another video on how to actually write recursive functions, but this is really essential to understand. How does recursion even work? Okay, it's all based on the runtime stack. Okay, so that's it for this video. Thank you.